Well, g'day and welcome back to my shop. Today's video is all about a Stuart steam engine. It's a model steam engine, and Stuart Castings are legendary amongst model engineers, and they produce some incredibly fine castings for model engineers over the years. This particular one was gifted to me by a good friend, or at least my good friend's father. So Keith, if you're watching this, I hope I can do justice to these castings that he's kept for all these years. Keith is someone I admired as a youngster. He paid attention to detail in everything he did. We're talking about a man who printed his contact details inside the hubcaps of his car. Just in case he lost a hubcap, he thought that someone would be able to contact him and return it. So as you can tell, this is some of the paperwork that he has kept all these years for this particular engine, and I haven't opened any of this, so today you're going to see the legendary unboxing. And I don't know why people watch these, but anyway, that's what we're going to do. And the castings are in this container here, and I remember him showing me these castings when I was about 16 or 17 years old, and I looked at them and I thought, wow, you know, I wish I had those and I could do something with them. Well, now I have. So we're going to have a look first at the drawings. So like I say, it's been many years, I imagine, since these were boxed up. And like everything that Keith did, this is very thorough. It's like it's been double wrapped. And to be honest, I don't even know what sort of engine this is. I believe it's some sort of mill engine, I think. Yep. So this is a horizontal mill engine, number 8. So I haven't actually done any research on this engine at all because I didn't know what it was. So we've got a casting list. Yep, number 8 engine. And these drawings are half size. So let's have a look at the castings. I think when he showed me originally, these were in a cardboard box, but looks like he's done his usual thing and packed them in a metal container. So once again, this is the sort of thing that Keith used to do. So he's put his cardboard label on there, double-sided, just to be sure. So there you go. Rough cast iron castings for Stuart, model steam engine, purchased ex-UK, circa 1967. So there you go. Alright, so I'm guessing that's a Stuart scale model catalogue. Yep, that'll be him. Everything's oiled. Still got the original wax paper. Looks like there's rod stock, some copper tubes, I'm guessing that's silver steel. Small copper tube. These would be for the steam piping. And in terms of castings, these are really fine, and you know, the surface finish on that is excellent. That's just going to need a little bit of a light filing to bring that up to the sort of surface finish that you'd expect on a model of this type. Steam chest cover, cylinder heads or cylinder ends, bronze casting for the main connecting rod. It's the cast iron flywheel, cylinder, and these are excellent because they've got the steam passages actually cast in. It would have been a really fine core that was used to make that passage. So this is the main body, if you like. So the crank bearing is going to go here, cylinder is going to bolt onto there. That's the rough arrangement of it there. I remember him showing me this. This is the displacement lubricator, all finished in brass, so no need to make that. And that's already polished up. That's going to be in perfect condition. And these are actually just filled with a steam oil, and as the live steam passes through on its way to the engine, a tiny amount of water condenses out into this chamber, and the water sinks to the bottom and raises the oil level back up that chamber, and it enters the steam line, so it carries on its way to the actual engine small droplets of steam oil atomized in the steam. They're actually the actual steam cocks. So cylinder would have a here we go, a means of actually allowing condensate out of the cylinder. When the cylinder is cold and the hot steam enters it, that's going to condense out to water, and if it's got no way of escaping, it'll create a hydraulic lock in the end of the cylinder and the engine's not going anywhere. So these drain cocks are going to be used to actually just vent the cylinder while it all warms up. That's the bronze casting for the eccentric. Looks like that'd be for the main bearings, and I'm guessing that's bronze, but it could be brass. Slide valve with the cavity already cast into it, so that saves some work there. Valve chest, that's a cast crankshaft, or it could be forged, I'm not sure. Won't know until we start machining that. Got the eccentric, that'd be the piston, and just a little bit more bar stock. Actually that'd be the connecting rod, and that would be the valve rod. Anyway, everything there is in excellent condition, as I imagine it would be, and over the course of the next couple of videos I'll be attempting to machine all of this and put it all together as a tribute to Keith, and I hope he enjoys watching it. So I'm sort of thinking that we're going to start with this part here. So I have no instructions on the correct sequence for machining this engine, so I'm going to start with this base casting here, and I have to machine the bottom edge and the top face. According to the drawing, its finished machining size is 27/32 of an inch. God, I hate imperial. Anyway, I converted that. It's 21.43 millimeters, and according to my caliper, that's around about, on average, about a millimeter over size. So I don't have a lot of machining allowance, so I'm going to have to clamp this down to the bed of the mill, just skim that bottom face, and once I've got a true surface I can invert that and machine in the top face, and each time trying not to take off more than about ½ millimeter. So as you can see, I've just bolted this down to the milling machine table with a couple of big heavy washers through what will be the top of the casting, and I've packed it on top of some thick copper sheets, because remember that's a cast surface against the milling machine table, so it's not perfect, and the copper will just sort of absorb any inconsistencies in the surface. So I'm just going to use a big end mill. I'm just going to touch off on this surface here and then basically just clean it up. I can't afford to go more than ½ millimeter deep, but I don't want, if I can, I want to go less than that, so I keep these flanges as thick as possible, and that will give me more opportunity to clean up the top. Right, so let's come over here to what looks like a low corner, and I'll just come up with the table until we touch off there. Okay, so there's a little bit of cast iron skin still here, so everywhere else we're machined. So I'm just going to give it one more skim. Okay, that looks good. So I think I took about 0.3 to 0.4 millimeters off the nominal height there, which is within my machining tolerance. So we'll flip this over and we'll do the top side. Okay, so my setup this time is I have a couple of toe clamps holding the end flange down. This one I've just got a bit of flat stock on top of the two pads, and this one I've got some round bar stock so that it will just roll as I tighten this toe clamp down. And I've just checked, I've got about 0.6 of a millimeter has come off the top. I'm going to touch off, do a skim cut, and then come back and check it. So I think I'm just going to use feeler stock just to set the Z this time. Okay, so that's 0.03. I'll just zero my DRO at that point. And we'll just go around and get this clean up. Okay, so I just cleaned up what appeared to be the low section there. I'll see if I can get a read on the height. Well, it's still showing 0.55 oversize. So I'm going to bring the Z up a fraction, say 0.2, and we'll run around again. About 0.33 to go. That's showing about 0.09, so I'm just going to do one more skim cut and I'll leave it there. It looks like I've come out about 0.03 under, which is not as good as I would have liked, but it'll do. Okay, well this part here is the bed of the engine, and it carries the cylinder on the circular face here and the main crankshaft across at right angles here. So it's going to be a bit of a challenge to machine this. The first step is going to be to establish a reference surface underneath here, and from there I have to be very sure that the bolting face for the cylinder is exactly at right angles or perpendicular to the reference face underneath. I also have to ensure that the actual geometry across that face will end up being perpendicular to the long axis of the engine as well. And of course the machine slots for the bearings will have to be parallel to that cylindrical face and a fairly critical depth as well. So all up, there's a lot of fairly critical geometry in the whole design, and just to complicate matters even further, there's really no easy way to bolt this down to the milling machine table to get that reference surface flat. It has draft on these faces here, so you can't grip it in a vise. It's a bit too flimsy to squeeze across this section here as well. So what I have noticed is that there is a flat section here and a very narrow flat section here. There's a couple of raised bosses at this end which are for bolting down to the engine base, so I can't use those, but I can fit a very narrow parallel in between this bearing section and that boss. And if I can bolt it down, no, that's not going to work. I'll need a bigger parallel, but if I can bolt it down that way, that's going to work. So just wait till I swap out my parallels. Okay, so I'm thinking that's going to be the setup there. I've made a couple of clamping plates that will go inside so I can get my bolts through into the T-nuts underneath. So it's not the most rigid setup. I'm only just taking light facing cuts on top here, so we'll see how we go, see if we get away with it. Well, there's the setup. I've bolted that down onto the parallel, so I've got studs going through the purpose-made blocks in the cavity into T-nuts in the T-slots. And I just wanted to be sure that I was pretty close with my surface here being parallel to the table. So I've run a dial indicator over it, and it's about 3/10 out from one end to the other. Now, I don't know if that's just sort of a faulty casting, or maybe I don't have it perfectly parallel, but I've also checked, and there's very little machining allowance on this part, so I'm just going to just clean it up and that's all. The critical part is this end where the circular flange for the cylinder bolting face goes, and the centre of that face has to be 1 1/8 inches off this surface here. And when I checked, it's I've only got a couple of maybe 20 thou to play with the machining. So if I go too far with this, that puts the 1 1/8 too far up on that circular boss, and then it won't look right when it's machined. So I'll just go very lightly and just take off the bare minimum. Okay, I think that worked alright. So I've just taken the casting skin off all the way around. Finish isn't bad. So I'll call it quits there, and that can now be turned over and go onto the previously machined base. Then I've got a lot of really accurate work that needs to be done. I'm going to drill all the mounting holes on the CNC mill, just simply because once I get a reference point I can do them all very quickly. So that might be the next step, to bolt these two parts together. You see I've got a little tiny bit of casting defect there, but given that that's going to be bolted down anyway, I don't think I'm going to bother with that. So there's the machine face fitting down against the corresponding face on the base. And it looks like there's 4 mounting holes for the engine bed and 4 for the base. So I think I'm going to do them next, so I can get this all put together in one part. It might make it easier later on for doing all of the second operations. Okay, well I've got to the point now where I need to drill the mounting holes in this base, and I've struck one of those dilemmas that you get when you're dealing with castings. If I find the exact centre of this casting, I get a scribe mark there, and then on the drawing it shows the distance between the mounting holes is, let's see, 1 3/8 inches, and if I set my dividers to half of that and mark out from that scribe centre line, the hole position ends up being out of alignment with the pad produced in the casting. So on one side it's off-centre toward the outside, on the other side it's sort of off-centre toward the inside. So these two features on the casting haven't been placed exactly on centre line. And so you have this problem, do you place the drill hole in the centre of the feature and have it asymmetrical, or do you place the holes exactly in the centre of the casting and then have them out of alignment with the pad? So I'm thinking in this case that since these drilled holes are going to hold this down to a piece of timber or a mock floor, I'm not too bothered about these being geometrically accurate according to the drawings. And that's probably going to horrify my good friend Keith. He'll probably think that I should do something with the casting and make that accurate before I drill out those hole positions. But I want it to look right. I don't necessarily want it to be geometrically accurate. These holes are non-critical anyway, so I'm going to place them exactly in the centre of the pads. On this piece I've got a similar problem. It's not perfect, and once again I want the drill holes to be accurately positioned in the centre of the features. So we'll just have to see how that pans out with this one. Yeah, I think that's going to be okay. So we're going to just lightly spot face that cast surface to give an accurate bearing for a screw or a bolt. Okay. So that's that one done. That's, apart from the holes and the threaded tapped holes for the studs that hold down the engine base, that part's more or less finished. I've just had a good look at the drawings here, and it seems like all the critical dimensions for this engine bed are taken from this cylindrical face. So we got a distance of 4 3/8 from that machine face back to the centre of the crankshaft. We've got a height 1 1/8 up to the centre line of the trunnion bore, which in turn will set the height of the bearing caps. So I've decided that the best thing to do is to actually finish that circular face and finish that bore before I go any further, and that will become my reference surface for everything else, and that gives me an accurate centre line for the centre of the crankshaft features. The actual drill holes for holding this down at the base are not quite so critical, so I'll do them later. The only problem is that the casting has a cord hole in this space, so if I try to set this up using the circular feature there as a starting point, I've got nothing in the middle to actually mark the center. So what I've done is I've machined up a small aluminium plug, and I'm just going to drive that into that cord hole. That's reasonably flush, and I'll just mark it out with some layout fluid, and I can start checking my distance from this already machined face. So I've got to set out a line 1/8" up from that surface there to locate the horizontal center line, and then I just use a center square or something like that to get my vertical center line. I can then accurately position that point, wherever that is, on my, I think I'm going to do this on the lathe using a angle plate. So I'm going to use my angle plate to locate that center and do all of the machining features on that face. Okay, so I've got my scribing block already set up to 1/8" off the table, and yes, I'm using my circular saw as a marking out table because I don't own a beautiful granite surface plate, but this is good enough. Right, so I'm just going to scribe a center line across here, and that's taking it through my aluminium plug, and I just need to locate another center line now vertically, and I think I'm just going to use a center square for this. Okay, so the center square is just going to give me an accurate center based on that circular reference, which is really all I need for the next step. So that scribed line doesn't necessarily need to be perpendicular to the machine base. I just want to get a location for the center of that bored hole or the cord hole, and once I have that established, it's going to be within 1/10 of a millimeter anyway. Once I have that established, everything else on the engine is going to work off that machine face. Okay, so this is the setup that I've got. I've got a large angle plate bolted to the face plate of my Colchester lathe. I've already clamped the casting down roughly in the center of the angle plate. I've got a couple of toe clamps there holding it down, and the best I could do was put a square along one side of the casting and get one edge more or less perpendicular to the front edge of the angle plate. Now, it's the best I can do because we don't have any flat surfaces or machine surfaces on this casting yet. Once I have this board and that faced, that's going to become the reference surface for everything else. So the angle plate at the moment is just bolted lightly to the face plate, and what I need to do is get my center that I've already scribed on that aluminium plug lined up with the tailstock center of the lathe. Okay, well, that took a bit longer than I hoped it would, but I've got that pretty close now. I'm just snugging down these nuts, and that keeps the angle plate in position. The problem I have now is that, as you can see, it's massively out of balance, so what I'll do is clamp a balance weight on this side. You haven't got to get it really accurate, it's just to offset some of the weight of the angle plate, and then I'm going to run this at low speed anyway. Okay, well, I literally did fit a balance weight to the faceplate, and it's not perfect, but I'll run it at this speed. So the first step is going to be just face that off and then machine the outer diameter, and then I'm going to bore the trunnion hole. Alright, so the drawing shows a diameter of 1.625 or 1.5", and none of these castings have a lot of machining allowance on them. So So that's 0.61 of a millimetre now, just to clean that up to that size. So I'm doing my metric conversions because my DRO is in metric. Well, actually does both, but I prefer to work in metric. So let's put that in the DRO. Okay, so I'm just going to chamfer that now, and then we're going to bore it out. Okay, I'm not going to get that back face with that tool, so I'll come back to that. Alrighty, so now you have to bore that out, and I've got a small boring tool I can put through there first, and then we'll try and finish it with a reamer. Okay, so I've got a small carbide tip boring bar, and I'm going to progressively cut through this length of the casting. It's got to go to 3/4 of an inch diameter, and it's about just over half an inch at the moment. So still a fair bit of material to come out of there, and it's not a continuous cut, so when it gets around to this section where the slot runs through, it's only going to be cutting on about half the material, and this boring bar, it's not particularly stiff, so I'll go in about halfway, then extend the boring bar, go the rest of the way, and then I've got a bigger boring bar to finish. If I can get it finished nicely with that, I'm happy. Otherwise I'm going to have to use a reamer, and reamers don't like doing interrupted cuts, so I'm not sure how that's going to work, but we'll see how we go. Alright, I'm about 2/10 of a millimetre undersized there, and I'm going to extend the boring bar and see if I can get all the way through to the back, but I know that this boring bar won't machine accurately to size. It's a bit too flexible, and yet to see whether I can get the bigger boring bar through here. Alright, so that'll reach all the way through. It sounded a bit terminal, yep. Just smash the point off that boring bar. Okay, turn that around. I just indexed that carbide around there. I'm sure you know that carbide doesn't like doing interrupted cuts, and it certainly doesn't like running at the speed that I'm running at, but it's the best I've got. I'll just try that again. Okay, well that's about 1/10 of a millimetre undersized. It's bored all the way through. It's cleaned up. all of the surfaces, so I have to make a decision now about whether I'm going to try and bore that to size or whether I should try and finish it with a reamer. I know my lathe doesn't turn absolutely parallel. I've got a problem with levelling the bed of the lathe on this concrete floor, so I don't always trust bored holes to be parallel along their walls. Okay, I'll just try that off camera just in case it was going to be a huge disaster. That it seemed to cut okay. If I can see where it's cleaned up the back of the bore, which was, I knew it was tapered, so it's cleaned that up. So I'm just going to increase this diameter a fraction at a time and then check it at the front. And when I got it 3/4, we'll leave it there. It's a bit screechy, but it does work. So I just ran that reamer through for the last time, and that bore is looking clean and polished all the way through, so quite happy with that. I just checked the diameter with a bore gauge. And it's showing 19.05. So there it is, 19.05, so that's close enough for me. And what I'll do now is just break that edge, put a chamfer on it, and we're done. So at this point there's no further operations I can carry out on there just yet. Later on I'll have to drill the mounting holes, but I'll probably do that some other way. I won't do it on here. So let's take that off and have a look at it. So you can see the surface finish on that bore there, and that was surprising actually that a straight reamer would do such a good job. So that entire casting now is sort of ready for marking out the position of the bearings, and once again that's done relative to that end face that I've already machined. So I'm going to have to do some bluing and marking out etc on this side here, and I'm going to have to somehow machine the tops of these bearings to the height shown on the drawing. So So that's sort of where we're at the moment, and I'm going to wind this video up here, and next time we'll have a look at least getting the bearings done. Okay, thanks for watching.